This will be the third video for the quadratic pattern, and the reason I want to do it, I want to show the intuitive way of figuring it out without going for all the algebraic solution. So far I remember it was step 1, 2, step 2, it was hopefully 5, 3 is 10, step 4 was 17, step 5 was 26, and so on. So if I want to visualize all this with small squares, the first one has 2 little squares, the second one has 5 little squares, next one has that makes it 6, 7, 8, 9, 10. And that'll do for the time being, and we should be able to figure out actually how to draw all these steps. It'll take some time. Now, well, some of the students possibly will think like this. So this one can be thought of as well, if we circle this part only, we got to redraw the whole thing, so 9 of those, and it's basically 1, 4. I'm only talking about the circled pattern, 9 plus something, plus one of these, 4 plus 1, and 9 plus 1. So I can visualize some kind of pattern, like say these are square numbers. We have to know what square numbers are, and that'll give you, if I go 1 squared plus 1, 2 squared plus 1, 3 squared plus 1. So basically what I'm doing, I'm squaring the step number, which is 1 for this one, 1 squared, plus 1 to make some adjustment. And this is the step number for the second one. This is the step number for the third one. So for a generalized number, which is valid for everything, universal, all kinds of situations, all the time it's true. It is true for any kind of numbers. That's what generalization is. It'll be n squared, any kind of number, n plus 1. And that gives me the number of squares, small squares required. So if we call it y, it's totally up to you how you call those variables. You might have called it squares, so instead of y you could have called it s. So number of small squares equals n squared plus 1. That is Another way of looking at the patterns and quadratics